What's up guys, this is Massey. Welcome to another video. In this video I want to talk about properties of determinants, and the first property I want to talk about is saying that when we change the rows to columns or columns to rows, the determinant of the matrix is not changing. So the value of determinant is not changed when rows are changed into columns and columns into rows. As you see here, we have rows like A's, B's, and C's, and then we have A's, B's, and C's. The determinant of these two matrices has to be the same. Let's find out using this matrix in here. So we need to find out the determinant of this 3 by 3 matrix. That's going to be 1 time 3 times 4, 12, minus 2 plus negative 2 times 0 plus 2 plus negative times negative 1 times 0 minus 3. That's going to be 10 minus 4 plus 3. That's going to be 9. Assume that we changed rows with columns. So that's going to be 0, 1, 0, 1, 0, 1, 2, 3, negative 1, negative 1, negative 2, 4. So if you want to find out the determinant, it's going to be 1 times 12 minus 2 plus 0 times 8 minus 1 plus 1 times negative 4 plus 3. That's going to be 10 plus 0 minus 1. That's going to be 9 as well. So if we change rows to columns or columns to rows, the determinant of the matrix is not changing at all. The second property is saying that if any two rows or columns of the determinant are interchanged, the sign of the determinant changes, but its magnitude remains the same. So if we have A1, A2, A3, B1, B2, B3, C1, C2, C3, and we change, for example, the second row with the third row, A1, A2, and A3 remains the same. We have C1, C2, C3, B1, B2, B3. The determinant is going to be the same but in opposite side. Let's have the same example. We have 0, 1, 0, 1, 2, 3, negative 1, negative 1, negative 2, and 4. We found that determinant A was 9 in the previous example. Now I want to have A double prime and switch the second row with the third row. So 1, 2, negative 1, 1, negative 1, 4, 0, 3, negative 2. So that's going to be 1 time 2 minus 12 plus negative 2, negative 2 minus 0 plus negative 1 times 3 minus 0. So that's going to be negative 10 plus 4, negative 3. That's going to be negative 13 minus plus 4 is going to be negative 9. So as you see here, the determinant is changed from 9 to negative 9. Next property is saying that a determinant having two rows or two columns identical has the value 0. For example, if we have matrix B equal to 1, 2, negative 1, 1, 2, negative 1, and we have 0, 3, negative 2. Let's see the determinant. That's going to be 1 times 2 times negative 2, negative 4, plus 3, plus negative 2 times negative 2, plus negative 1 times 3. That's going to be negative 1 plus 4 minus 3, which makes it 0. So when we have any matrix that have two identical columns or two identical rows, we have 0 as determinant. Property 4 is saying that multiplying all the elements of a row or column by a scalar, which is a real number, is equivalent to multiplying the determinant by that scalar. For example, as you see here in this row, we multiplied all the elements by lambda. The determinant of it is going to be lambda times determinant of the original matrix. For example, the example we had, I'm going to call it matrix A. That was 1, 2, negative 1, 0, 3, negative 2, 1, negative 1, and 4. Determinant of A was 9. Now if I multiply the first column by 2, we're going to have 2, 2, negative 1, 0, 2, 3, negative 1, negative 2, and 4. So that's going to be basically 2 times 12 minus 2 plus 2 times negative 2 times 0 plus 4 negative 1 times negative 6. 20 minus 8 plus 6. That's going to be 18. So as you see here, 18 is 9 times 2. And we multiply the column 1 by 2. Now, next property is multiplying all the elements this time, not just one row or one column, all elements by lambda. The determinant is going to be lambda to the power of size of the matrix. In this case, it's 3 by 3, so lambda to the power of 3 times determinant of the original one. So if I say, referring back to A again, 1, 2, negative 1, 0, 3, negative 2, 1, negative 1, 4. And we said determinant of A is 9. Now, if we basically multiply all the elements by 2, I'm going to say A2 is going to be 2, 4, negative 2, 0, 6, negative 4, 2, negative 2, 8. That's going to be 2 times 48 minus 8, negative 4 times positive 8, negative 2 times negative 12. That's going to be 80 plus, actually minus 32 plus 24. That's going to be 72, which is 9 times 2 to the power of 3, which is going to be 9 times 8. So that's why we got 72. Why 2 to the power of 3? Because the size of the matrix is 3. So 2 to the power of 3 times 9 is going to be 72. So these are the most important properties of matrices. I hope you enjoyed this video. Please leave me a comment if you have any question. And please don't forget to subscribe to this channel. You can have access to many other videos regarding matrices and other topics in math, chemistry, and physics. Thank you for watching and have a great day.